Example 5, we're going to look at rolling a die and tossing a coin. An experiment consists of rolling a die and then tossing a coin. How many elements are in the sample space? So this is asking how many possible outcomes are there? Well, if I use the multiplication principle, remember that you take the possible outcomes of each event and multiply them together. So when we roll a die, there are 6 outcomes. When we toss a coin, there are 2 possible outcomes. So when we combine the 2 in a sequence of events, we get 12 possible outcomes. Now, if you would like, just for practice and to convince yourself that this is true, you can actually write out the sample space. In this example, it's small enough that you can do that. So when we list a set for a sample space, we use curly braces. I'm going to indicate the number on the die by literally writing that number, and then I'll use T for tails and H for heads. When I put them together, I could get a 1 and then heads. I could get a 2 and then get heads. I could get 3 on the die and then get heads. I could get 4 and then heads, 5 heads, and then 6 and heads. Then I repeat that with tails. I could also get a 1 with a tail, a 2 with a tail, 3 with a tail, 4 with a tail, 5 with a tail, and then 6 with the tail. So you can see when we list it out, there are 12 possible outcomes. So this is our sample space written out. In part B, it says, let A be the event that a 2, 3, or 4 is rolled, followed by landing on a head. Find the probability of A. So event A consists of getting a 2, 3, or 4, and then a head. So our options for event A is we could get a 2 and a head, we could get a 3 and a head, or we can get a 4 and then a head. So to find the probability that event A happens, we want to take, right? Remember the favorable outcomes divided by the total possible outcomes. Now, we just figured that by writing out the sample space up above. We know that there are a possibility of 12 outcomes. So that's going to go in the denominator. Now, our favorable outcomes, those are the outcomes that are in event A. So we could get a 2H, a 3H, or a 4H. That's 3 possibilities out of 12. I can reduce it to 1/4. That's 3/12, but we can reduce it to 1/4. So that is our answer for part B. Let's look at part C. Let B be the event that you get a number less than 2 when you roll the die, and then you get a head when you flip the coin. Event B can only be one possible outcome. There's only one number that's less than 2 on the die. That's 1. And then if we get a head when we flip the coin, only one possible outcome. It's outcome 1H. Are A and B mutually exclusive? So remember, mutually exclusive means that they can't happen at the same time. They don't have anything in common. So when I look at event A, there is nothing in common. We don't have 1H in A, and we don't have 2H, 3H, or 4H in B. So since there's no overlap and they don't have anything in common, we would say yes, they are. I'm going to abbreviate ME for mutually exclusive. And then I'm going to put in parentheses because they have nothing in common.